In Apollo 11, when they got there, Buzz Aldrin and Neil Armstrong hopped into the LEM to go to the surface, leaving Michael Collins, a third astronaut, all alone.
Collins was a member of the historic Apollo 11 mission, where humans took their first steps on the moon.
Who were the first humans on the moon? If you say Neil Armstrong and Buzz Aldrin, you aren't wrong. However, there is a third astronaut that remains in obscurity because of his particular role in the historic occasion, but now he has come out to reveal spooky secrets about the mission to the moon. Who is this astronaut and what has he revealed that's shocking about going to the far side of the moon? Stay tuned to find out. That's one small step for man, one giant leap for mankind. Most people recognize this iconic statement uttered by Neil Armstrong as he took his first step on the moon, closely followed by fellow astronaut Buzz Aldrin. While the statement deserves its position in the annals of humankind, there is a third astronaut in the picture, even though many people might not know about him. That was Michael Collins, the man whose job was to remain in the moon orbiting command module. Now, the moon has always been a source of wonder and inspiration for humanity. Since ancient times, people have observed its phases, cycles, and eclipses, and associated it with various myths, legends, and beliefs. The moon has influenced our calendars, tides, festivals, and art. Some even claim the moon can affect humans mentally. It has also sparked our curiosity and imagination as we wondered what it was like to visit this mysterious celestial body. The first attempts to explore the moon were made by sending unmanned probes into orbiters such as the Soviet Lunar and the American Ranger and Surveyor programs. These missions provided valuable information about the lunar surface, geology, and environment. However, they also increased the desire to send humans to the moon, especially during the Cold War era when the space race between the US and the USSR became a symbol of national pride and technological superiority. The US launched the Apollo program in 1961 with the goal of landing a man on the moon and returning him safely to Earth before the end of the decade. This was a bold and ambitious challenge requiring enormous resources, innovation, and courage. The Apollo program involved several stages of development and testing, including suborbital and orbital flights, rendezvous and docking maneuvers, lunar orbiting and landing simulations, and extravehicular activities. The culmination of the Apollo program was the historic Apollo 11 mission, which took off on July 16, 1969. The crew consisted of Armstrong, Aldrin, and Collins. After reaching lunar orbit, Armstrong and Aldrin separated from Collins in the lunar module Eagle, while Collins remained in the command module Columbia. On July 20, 1969, Eagle descended to the lunar surface while millions of people around the world watched in awe and anticipation. At 2:56 GMT, Armstrong became the first human to step onto the moon, uttering his famous words quoted earlier. He was soon joined by Aldrin, and together they spent about 2 hours on the moon collecting samples, planting a flag, talking to President Nixon, and performing scientific experiments. They also received a plaque that read, "Here men from the planet Earth first set foot upon the moon at July 1969 AD. We came in peace for all mankind." After reuniting with Collins in orbit, the three astronauts began their journey back to Earth. They splashed down in the Pacific Ocean on July 24, 1969, completing their historic mission. They were greeted with celebrations, parades, honors, and admiration from people of all nations. They had achieved what many thought was impossible or unthinkable. They had fulfilled a centuries-old dream of humanity. They had touched the moon. Now, Collins was a remarkable man who had a distinguished career as a pilot, test pilot, astronaut, and general. He was born in 1930 in Rome, Italy, where his father was a U.S. Army officer serving as a military attaché. He grew up in a military family, moving frequently to different countries and states. He attended St. Albans School in Washington, D.C., where he developed an interest in aviation and astronomy. He graduated from the U.S. Military Academy at West Point in 1952 and chose to join the Air Force. He became a fighter pilot and flew missions in the Korean War. He later attended the Air Force Test Pilot School at Edwards Air Force Base in California, where he tested various aircraft, including jet fighters and bombers. In 1963, he was selected by NASA as one of the third group of astronauts, along with Buzz Aldrin. He trained for the Gemini and Apollo programs, which aimed to achieve crewed orbital flights and lunar landings. He made his first spaceflight in 1966 as the pilot of Gemini 10 along with John Young. They performed 2 rendezvous with other spacecraft, and Collins performed 2 spacewalks. He was originally assigned to be the backup command module pilot for Apollo 8, the first mission to orbit the moon. However, he had to undergo surgery to remove a bone spur on his spine, which sidelined him for several months. He was then reassigned to Apollo 11, the first mission to land on the moon. He became the command module pilot, while Armstrong became the commander and lunar module pilot, and Aldrin became his crewmate. But as an astronaut that largely worked in the background, so to speak, what was Collins' role on the Apollo 11 mission? As the command module pilot CMP of Apollo 11, he actually held a role of tremendous responsibility guiding and maintaining the command module Columbia, which would serve as the mothership for the lunar landing. And so, in the vastness of space, while Armstrong and Aldrin embarked on their historic lunar exploration, Collins remained in lunar orbit, piloting at the command module. His role, although less visible, was vital and filled with complexity. To begin with, Collins was responsible for the undocking procedure, a critical moment when the lunar module Eagle carrying Armstrong and Aldrin separated from the command module Columbia. An error here would have had severe implications, potentially jeopardizing the safety of the crew and the success of the mission. Once the lunar module departed for the moon's surface, Collins found himself as the solitary inhabitant of Columbia. This period has often been framed as one of isolation, but in reality, it was far from a passive role or just sitting around. His task list was heavy, consisting of monitoring systems, communicating with mission control, and preparing for the critical rendezvous and docking procedures with the lunar module after its ascent from the lunar surface. In fact, the act of rendezvous and docking was one of the most technically challenging parts of the entire Apollo 11 mission. It required Collins to precisely calculate and execute a series of maneuvers, a process riddled with potential pitfalls. Any miscalculation could lead to the lunar module being unable to dock with the command module, a scenario that would leave Armstrong and Aldrin stranded in lunar orbit. Another crucial task assigned to Collins was to ensure the well-being of the command module during the lunar module's excursion. The command module was the crew's only vehicle for the return journey to Earth, and maintaining its systems was, of course, crucial. Collins had to routinely check the spacecraft's systems, ensuring that life support, communication, and propulsion were all functioning optimally. And to be clear, his duties extended beyond the mechanical and into the observational. Collins was the mission's primary source of information about the lunar surface's observable features. As Columbia orbited the moon, he took photographs and made observations that were invaluable to the scientific understanding of the moon. And there is one aspect of Collins' duties that is not often talked about beyond those technical responsibilities. Collins bore a tremendous psychological load. He was the mission's linchpin, the connecting link between Earth and its 2 explorers on the lunar surface. This placed him in a unique and immense position of responsibility. He knew that should anything go awry on the lunar surface, he would have to make the agonizing journey back to Earth alone. Yet Collins carried out his duties with incredible calm and composure, embodying the right stuff that characterized the astronauts of his era. He remained collected and focused, maintaining constant communication with mission control and diligently carrying out his assigned tasks. His careful and precise execution of each step of the mission was an integral part of the successful completion of the lunar landing. And Collins' work continued even after the successful rendezvous and docking with the lunar module. He played an important role in the Trans-Earth Injection at TEI, a critical maneuver that involved firing the spacecraft's engines to leave lunar orbit and set the course back to Earth. Once again, Collins' technical skill and precision were key to the successful execution of this maneuver, underscoring his vital contribution to the mission. But his role was not just about piloting the spacecraft, it was also about representing the mission's humanity and camaraderie. Despite being physically separated from Armstrong and Aldrin during the lunar landing, Collins was united with them in spirit and purpose. His work, his dedication, and his courage stand as a testament to the collaborative and collective effort that defined the Apollo 11 mission. But Collins has often spoken about being alone in Colombia and how it affected him in profound ways. But what exactly was the experience like for this astronaut, and what did he discover about himself and the rest of humanity? His reflections on this experience provide us with a glimpse into the profound impact it had on him and, in turn, on humanity's understanding of our place in the universe. As the lunar module descended to the moon, Collins remained aboard the command module, entering a solar orbit around this alien world. He spent over 21 hours in lunar orbit, of which 48 minutes of each orbit was spent in utter radio silence on the far side of the moon, cut off from both his fellow astronauts and mission control. This phase is often referred to as the loneliest man in history, yet Collins' perspective on this experience was one of serene solitude rather than stark loneliness. But why exactly was Collins cut off from the rest of humanity for 48 minutes during each orbit? Well, Collins was cut off from the Earth for 48 minutes on the far side of the moon because of the moon's blocking effect on radio signals. Radio waves are a form of electromagnetic radiation that can travel through space, but they can also be blocked or absorbed by solid objects, such as planets and moons. When Collins orbited behind the moon, he was out of the line of sight of any Earth-based transmitter or receiver and thus could not communicate with mission control or anyone else on Earth. This situation was unique to Collins, as he was the first person ever to venture to the far side of the moon completely alone. The Apollo 8 crew had also orbited the far side of the moon in 1968, but they were together in the same spacecraft. The Apollo 11 lunar module Eagle had also landed on the near side of the moon, which always faces Earth and is in constant radio contact. Collins had to wait until he emerged from behind the moon to regain contact with his crewmates and Earth. And the far side of the moon is not only radio silent, but also radio quiet. This means that it's free from any radio frequency interference, RFI, that's generated by human activity on Earth, such as TV and radio broadcasts, communication signals, or other forms of electromagnetic noise. This makes it an ideal location for radio astronomy, as it can detect weak signals from the sun or beyond that are otherwise drowned out by Earth's RFI. The far side of the moon also lacks a substantial ionosphere, which is a layer of charged particles in Earth's upper atmosphere that can absorb and refract cosmic radio sources. And this radio silence and quietness on the far side of the moon has attracted scientific interest and exploration for a while now. In 2019, China's Chang'e 4 mission became the first to land a spacecraft and a rover on the far side of the moon in the Von Karman crater within the South Pole Aitken Basin. One of its objectives is to conduct low-frequency radio astronomical observations using a small antenna deployed by the rover. It also relies on a relay satellite which orbits a point called the Earth-Moon L2 Lagrangian point, where gravitational forces are balanced and allow it to communicate with both the lander and the Earth. The far side of the moon is a fascinating and mysterious place that offers unique opportunities and challenges for communication and exploration. Collins was the first to experience its solitude and silence, but he was not lonely or bored. He enjoyed the view of the Earth and the moon, kept himself busy and focused, and maintained his humor and curiosity. He also played a vital role in the success of Apollo 11, as he had to perform a crucial maneuver to dock with Eagle after the lunar landing and bring his crewmates back to planet Earth. In his own words, Collins didn't recall feeling lonely. Instead, he relished the quiet moments. He felt a strange sense of peace and awareness, anticipation, satisfaction, confidence, almost exultation. For Collins, the solitude was a welcome escape from the usual bustle and intensity associated with the mission. While circling the moon, Collins was also privy to a view that only a select few humans have seen: the lunar far side, a rugged, crater-filled landscape untouched and unseen from Earth. And as he looped around, he would see the Earthrise, a breathtaking sight of our home planet emerging from the lunar horizon. This view of the Earth, small and fragile against the infinite expanse of space, was an awe-inspiring spectacle that left an indelible mark on Collins. The unique vista stirred feelings of profound connection and insignificance. Earth, with all its life and civilization, was just a tiny blue dot on the grand cosmic canvas. This perspective, commonly referred to as the overview effect, fundamentally shifted Collins' perspective of our planet and our place in the universe. He experienced an acute sense of the interconnectedness of all life on Earth and a deep understanding of our planet's fragility. Such revelations instilled in Collins an enduring sense of environmental responsibility. Post-Apollo, he became an ardent advocate for Earth conservation, urging humanity to take better care of our planet. He often expressed his hope that one day all political leaders could see Earth from his vantage point so they could appreciate the need for cooperation and conservation. His lunar solitude also led him to grapple with existential questions, further reshaping his worldview. In his autobiography, Carrying the Fire, Collins pondered the meaning of the universe and our role within it. The experience honed his belief in a universe designed with purpose and order. He wasn't overtly religious, but his journey into space enhanced his spiritual outlook, emphasizing an organized cosmos rather than chaotic randomness. Being the loneliest man wasn't a burden for Collins, it was a badge of honor, a unique experience that he embraced with grace and gratitude. It provided him with a unique perspective, enriching his life and broadening his horizons. The experience shaped his values and attitudes, influencing his post-NASA life, where he served as an Assistant Secretary of State for Public Affairs, Director of the National Air and Space Museum, and a writer. Collins' time alone in lunar orbit was also a testament to his courage and resilience. His unwavering focus and unshakable calm, despite the enormous responsibility and the palpable risk, are a testament to his character. But there was one secret terror that Collins nursed in those hours that he was alone, a dread of a particular scenario that, should it come to pass, would forever mar the mission and burden his soul. The fear that Armstrong and Aldrin might not return from the lunar surface. While millions of people worldwide basked in the euphoria of the moon landing, Collins was already grappling with the next major challenge: the lunar module's liftoff from the moon's surface and its rendezvous with the command module. The success of the mission and the lives of Armstrong and Aldrin hinged upon the lunar module's ascent engine firing correctly. Unlike every other major system on Apollo 11, there was no backup for this engine. It had to work. Failure meant Armstrong and Aldrin would be stranded on the moon with no hope of rescue. Collins confided this fear to a few people before the mission, dubbing it his secret terror. He meticulously reviewed rendezvous procedures and checked and rechecked systems, running scenarios in his mind about what he might have to do if things didn't go according to plan. The weight of this fear was palpable. Collins was acutely aware that should the worst happen, he would have to return to Earth alone. He would be the solitary survivor of an expedition marked by camaraderie and collective effort. The psychological impact of such a scenario was daunting. He would be forced to carry the memory of his stranded colleagues, their dream of lunar exploration turned into a perpetual lunar exile. And his dread was further compounded by the awareness that he would be the one to inform the world of this tragic failure. He would have to face the families of Armstrong and Aldrin, share the devastating news with them, and then relay it to millions across the globe who had cheered the brave astronauts on. And yet, despite the enormity of this terror, Collins did not allow it to paralyze him. Instead, he channeled it into his duties, working with precision, focus, and determination to ensure the success of the mission. His fear, rather than being a hindrance, served as a motivator. He knew the risks and understood the stakes, but he also recognized his responsibility and the trust placed in him by his colleagues and his nation. His actions during the mission, his meticulous attention to detail, and his readiness to handle any situation speaks volumes about his professionalism and resolve. Even as he battled his secret terror, Collins continued to exude confidence and calm. His composed demeanor provided a reassuring presence for the team at Mission Control and his fellow astronauts. And indeed, the dreaded scenario never came to pass. The lunar module's ascent engine functioned perfectly. Armstrong and Aldrin returned safely from the lunar surface, and the rendezvous with Collins in the command module was executed flawlessly. The Apollo 11 mission was a resounding success, but nevertheless, the shadow of Collins' secret terror adds a nuanced perspective to this historical event. This sphere, kept mostly hidden from the world, underscores the human aspect of space exploration. It reminds us of the emotional and psychological battles the astronauts fought behind the scenes, the personal demons they wrestled with while making giant leaps for mankind. Colin's secret terror is an essential part of his Apollo 11 story. It underlines his courage, resilience, and dedication. Colin's secret terror is an essential part of his Apollo 11 story. It underlines his courage, resilience, and dedication. He faced his fear head-on, accepted its presence, and yet did not allow it to derail his mission. His ability to function under such stress is a testament to his character and the caliber of astronaut he was. In many ways, Colin's experience with his secret terror encapsulates the spirit of the entire Apollo program. It was a journey fraught with risk and fear, but also brimming with courage, determination, and a relentless pursuit of a lofty goal. It showed that even in the face of profound dread, humanity could rise, conquer its fears, and achieve the extraordinary. Through his secret terror, Colin shows us that heroes aren't fearless, but are those who choose to move forward despite their fears. His experience reminds us that behind the glory and triumph of the Apollo 11 mission were human beings wrestling with their anxieties and uncertainties, making their achievements all the more remarkable. The moon voyage also underscored for Collins the power of teamwork and collaboration. He acknowledged the Apollo missions were not about individual heroes, but a collective effort of hundreds of thousands of dedicated individuals. This understanding led him to value and champion collective efforts in achieving challenging objectives. In the end, the voyage ultimately did more than take Collins to the moon. It took him on a journey into the self, transforming his perspective on life, Earth, and humanity. His experiences and reflections remind us that even in the most isolated corners of space, we are intrinsically linked to the universe and to each other. But what exactly makes the far side of the moon difficult to explore? Well, there are several reasons. The first reason is the lack of direct communication with Earth. Radio waves, which are used to transmit data and commands between spacecraft and ground stations, cannot penetrate the solid body of the moon. Therefore, any spacecraft or rover on the far side of the moon is out of contact with the Earth for half of each orbit, or about 48 minutes, as was the case with Collins. What this means is that any mission to the far side of the moon requires a relay satellite to communicate with Earth, which adds complexity and cost to the operation. It also means that any rover on the far side of the moon has to operate autonomously without human guidance or intervention. The second reason is the rugged terrain and harsh environment of the far side of the moon. The far side of the moon has a thicker crust, higher elevations, more craters, and less volcanic activity than the near side. It also has fewer maria, which are dark plains of solidified lava that cover much of the near side. The reasons for these differences are not fully understood, but may be related to the early history and asymmetry of the moon. The far side of the moon also has extreme temperature variations ranging from about minus 173 degrees Celsius or minus 279 degrees Fahrenheit at night to about 127 degrees Celsius or 261 degrees Fahrenheit during the day. These conditions pose challenges for the landing, navigation, and survival of spacecraft and rovers on the far side. The third reason is the limited knowledge and data about the far side of the moon. The far side of the moon was first seen in a handful of grainy images returned by the Soviet Luna 3 probe in 1959. Since then, only a few missions have orbited or landed on the far side of the moon, such as NASA's Lunar Orbiter and Lunar Reconnaissance Orbiter, China's Chang'e 4, and India's Chandrayaan 2. Compared to the near side of the moon, which has been extensively mapped and sampled by various missions, including 6 crewed Apollo landings, the far side of the moon remains largely unexplored and unknown. And yet, despite these challenges, scientists continue to study this lonely side of the moon because there are also many benefits and incentives for exploring the far side. The first benefit is that the far side of the moon may hold clues about the origin and evolution of the moon, as well as its internal structure and composition. For example, one of the most prominent features on the far side of the moon is a large impact crater called the South Polar Aitken Basin, which is one of the oldest and deepest craters in the solar system, and it may have exposed the lunar mantle, which is the layer below the crust, and may contain valuable information about how Earth's satellite was formed. Another example is evidence of water ice in permanently shadowed regions near the lunar poles. These regions are extremely cold and dark and may preserve water ice that was delivered by comets or asteroids over billions of years. And water ice happens to be a valuable resource for future exploration and potential colonization of the moon.